Dear students, a very good morning. Today we are going to discuss about system design techniques in embedded system. Okay, so it is a very important concept. Okay, how to design a system. So let's see the introduction about designing methodologies. Embedded systems are the backbone of modern technology, powering devices and machinery across the various industries. The design of embedded system present unique challenges due to constraints such as limited resource, real-time requirements, and a diverse applications domain. In this presentation, we are going to discuss about how to design a embedded system and what are the methodologies are involved. So, design methodologies provide a structured approach and frameworks for managing the complexity of embedded system design. They offer systematic method for requirement analysis and system architecture design, implementation, testing, and maintenance. By following established design methodologies, embedded system designer can streamline the development process, reduce risk, and improve the quality of the final product. Next important design methodologies is waterfall model. What is waterfall model and its application? It has a different phases starting from the requirements, design, implementation, verification, and maintenance. The advantages are clear structure, well defined milestone, and documentation. Disadvantages limited flexibility, challenges in accommodating change late in this process. So, waterfall method has the disadvantage limited flexibility, challenges in accommodating changes late in the process. And that's why we go for agile methodologies. Agile development is an iterative and flexible approach to design that emphasizes collaboration, adaptability, and continuous improvement. It involves breaking down the development process into small incremental steps, allowing for frequent feedback and adjustment. The key principles of agile development include iterative development, customer collaboration, continuous improvement. These are the key principles. The first thing is iterative development. So iterative development in embedded system means building a software step by step, fixing and improving it along the way. So iterative development has little by little feedback helps adapting to change. Embedded system often need to change because of new requirements or problem. Iterative developments let developer adjust the software as they go, making it easier to handle changes. Next one is the design methodology spiral model. So till now we discussed about waterfall model and agile model, and then a spiral model. The spiral model is like a roadmap for building an embedded system, which are device both with both hardware and software like a smartphone and smartwatch. First, we have to, in a spiral model, we have to set the goal and thinking about the risk. After that, making test version or piloting model, building a bet. Next one is the design sprint. Design sprints are the way to solve problems and test idea fast. Get ready, gather a team with a different skill like engineers and designer, figure out what problems you are trying to solve. Learn about the system. Understand the system you are working on, including what user need to and what the technical limits are. Then brainstorm idea. Everyone come up with ideas for solving the problem, thinking about both our hardware and software parts of the system. Pick the best idea, share and discuss the ideas. Choose that one that seem the most promising and realistic. Successive refinement. What is mean by successive refinement? It starts with the big picture, break it down, work on each phase, iterate and improve. Hierarchical design flow. Hierarchical design flow, starting at the top and breaking it down, working on each layer, setting a clear boundaries. This is the designing a process of hierarchical design flow. Test driven development. Write a test first and the test implementation, run test, refactor code. After that, hardware software co-design. So the hardware software co-design is a design methodology commonly used in embedded system development to optimize the interaction between hardware and the software component. So that's why it is called a hardware software co-design. Working together, understanding needs, talking to each other. System analysis. System analysis involving studying a system to understand its component, their interaction, and the system's behavior as a whole. This process aims to identify the requirements, constraints, and objective of the system. For that, we have to first gather the requirement gathering, feasibility study, and modeling, risk analysis. That's why we are using system analysis in the design methodologies. Next one is the architecture design system analysis process. How we can go for system analysis process means first we go for the architecture design. Architecture design involves defining the structure, components, and interaction of the software system to meet its requirement while satisfying constraints such as performance, scalability, and maintainability. This phase translates the requirements identified during the system analysis into the blueprint for a system implementation. Identify the stakeholder system analysis process. First, we have to identify the stakeholders, define system scope, gather requirements, analyze the requirement, model the system, define system interface. Okay, what are the importance of system analysis? A system analysis used to do risk mitigation, okay, and also enhanced communication, improved system design. So enhanced system analysis facilitate effective communication between stakeholder including end user, clients, developer, and project manager. So clear communication on of a requirement and system model helping conveying ideas, clarifying expectations, and ensuring everyone is on the same page throughout the development process. Understanding the user need, requirement clarification, cost and time optimization. So types of architecture design, monolithic architecture design, layered architecture design. We have a two types of architecture design. One is the monolithic and another one is the layered architecture. Okay, so what is mean by monolithic and layered? And another one is the client server architecture and event driven architecture, service oriented architecture, then microservice architecture design process. So till now we discussed about what are the architecture to design a system. So in that how architecture design is process. Okay, understand first we have to understand the requirements, then identify the stakeholder, define system scope, identify architectural drivers, select architectural styles and pattern, decompose the system. What's the importance of architecture design? It is a blueprint for developments. It can be scalability. We can increase the scalability of the system through the architecture design, and there is a maintainability. A well-structured architecture promotes modularization and encapsulation, making it easier to maintain and update the system over the time. Okay, flexibility and adaptability, performance optimization, security. Okay, now what are the challenges in architecture design? It is a complexity management, handling the increasing complexity of the software system, scalability, designing for growth without sacrificing the performance or reliability, performance optimization, meeting performance requirement while minimizing bottleneck, maintainability and evolvability, ensuring the architecture is easy to maintain and adapt over time. Security and compliance, incorporating security measures and adhering to regulation. Interoperability and integration, facilitating seamless integration with the external system. Technology selection and adoption, choosing the right tool for and the frameworks for the architecture. What are the solutions in architecture design? It provides a modular design, scalability planning, performance profiling, continuous refactoring, security by the design. Okay, so guys, I hope you understand what is system design techniques and what are the system design techniques. Methodologies are available like agile, spiral, like that. After that, system for system design, we need to define architecture and what are the process to design the architecture. We discuss. After that, now it's the time for assessment. Okay, so the first question is break down the system into modular components to manage the complexity and promotes maintainability is called division of operability. Okay, use performance profiling tool and the techniques to identify the bottleneck and optimize critical component is called performance profiling. Okay, after that, embedded system are the backbone of modern technology and powering device and machinery across the various industry. Okay, so thank you students. I hope you understand embedded system design techniques and methodologies. So thank you all. Have a great day.